I know I personally I was working on
You want to give take a pass at the formative evaluation this week and see how it goes? Is that what you want to see? And then we got 3 weeks to fix everything that may or may not, plus add about a half a dozen new concepts over the next couple of weeks. But stats is one of those things that you can't learn except by doing. You have to jump into it and mess with it and see what happens. And that's about the only way you can get there. And so it is it's a different sort of approach. You almost have to stumble and be a little bit confused before you can get out the other side. But as I've indicated several times, it's a simple enough logic and a simple enough process that there's nothing that really limits anyone from kind of getting a grasp on it. You just have to let go of your misconceptions and your insecurities about being able to do it or whatever. I mean, trust me, if I can do it, you can do it. No big deal. It's just a matter of launching into it and having a little confusion and a little bit of failure and things like that and working through it and then come out the other end. It's like any other sort of learning. So what's holding you up? What's hanging you back?
Can you hear me? Hello?
I can hear you, Katie.
I can hear you,
Okay.
Katie.
Sorry, guys. I thought I was going crazy there.
Try that again. Okay, give it a whirl.
Can you hear me now?
Oh, yeah, I can hear you.
Okay. I know I was working on the midterm, and I was getting a little confused about the 95 percentile minimum and maximum question.
Sure.
So I was looking at it, and I was, I ran my descriptive or whatever, and I was like, okay, well, I wonder if.
Okay, I kind of lost you there.
You're breaking up.
But I think I know what your essential question is, and it's a simple enough one to answer. And so let me see if I can do that. Let me see if I can get over on my little whatchamajigger here.
Does this use the quartiles, Dr. Bolt?
No, it really, well, yeah, it could. You could, but it's a different, it's a much simpler way of getting there. And so let me see if I can kind of get you there. Essentially, you need two things. You need a mean value. This thing's acting crazy today. You need the mean and whoa, slow-mo, and the standard deviation. That's all you need. You need those two things. And if the way in which the normal distribution works is that it's divided into units by standard deviation units. And so the mean is at the center. That's the mean. And if it's a population mean, we use the mu. If it's a sample mean, we use the X bar on top. I don't know why the delay here is on this thing, but rather than try to figure that out, we'll just kind of work through it. And within, if you look at the information on standard deviations and on normal distribution, you realize that one standard deviation unit above or one below, each one of those occupies about 34% of the space. And remember, percentiles are measure of area, AREA, in case you can't get past my hillbilly North Carolina, Virginia mountain dialect. And so 68% of the space in the normal distribution is between one standard deviation down and one standard deviation unit up. And if you go up to the second one, and what then you find is that between those two areas, between 2 up and 2 down, is about roughly 95% of the space. And so to understand what's, lies within that middle 95% of the distribution, it's just a simple little math problem of the mean plus or minus 2 standard deviation units. And so let's say the mean was, go back up here. Let's say the mean was 50. And the standard deviation was, I don't know, 5. Then that means the 95th percentile would lie between 50 minus 2 standard deviations, 50 minus 10, 40, and 50 plus 2 standard deviations, which would give you 60. And so 95% of the cases would lie between a value of 40 and 60. Now, it's really easy to get that notion confused with, put this down a little bit, get that notion confused with things like minimums and maximums. And minimum is simply the lowest value and maximum is the highest value. And so when you talk about things like quartiles, essentially it's taking the same standard deviation, the same standard normal distribution, and instead of dividing it by standard deviation units, we just divide it by 25% of the space. So you have 4 sections that each has 25% of the space, or roughly 25% of the cases. And so quartiles talks about, the dividing the total distribution into 4 roughly equal increments. Stainines talks about dividing the same space into roughly 9 equal increments. The way in which AP exams are done is in a quintile, and so it's just a matter of taking the same amount of space and dividing it up into roughly 5 equal increments by distance. But they all are still talking about the same normal distribution. It's just a way of dividing up that normal distribution. And so if you're talking about, what values determine the middle 95%, well, it's the, the standard, the mean of the information, mean of the data, plus or minus 2 standard deviation units, and that gives you the middle 95%. In the social sciences, early on in the early part of the 20th century to mid 20th century, and still, if you look at social work curriculum or some sociology curriculum, they'll call it the rule of 2s. That things are, significantly different, or an individual is significantly different if they lie further than 2 standard deviation units away from the mean. And so you may see that rule of 2s referred to sometimes. And that's just the same thing. It's just the middle 95%.
Awesome. That was helpful. Thank you.
Okay.
So like on the midterm question Katie mentioned, the minimum and the maximum in that question, you're just wanting to know what those actual values are, like the 40 to 60 you just calculated.
Right, yeah.
Okay.
And it's just a simple math problem. That's all it is. And so but it is an understanding of the whole notion of significance is an arbitrary one. And the way that we got to, the 95% and the 5% less than 0.05 is essentially the same logic. This is the 95% in the middle here. And if you have a value that lies out here or out here, then those are values that are in the 5% range, and we would call those values significant. Now, does something not being significant mean that it's not useful to look at? No. Think about if we say something is not significant, and instead of 0.05, let's say it's 0.10. That still means that we're, instead of looking at the outside 5% here, we're looking at slightly more area, the outside 10%. But it may still mean that information is important to know, because a value at that point, although it's not classically defined as significant, it might be useful to know that 90% of the time you'll have a value that's more toward the middle, and that might be an important thing to know. Now, it might not, won't get you published, or it won't get, it won't be in a report somewhere as being a significant value. But if somebody told me that I could, there was a bet that I could place and I had a 90% chance of winning, I'm probably weak enough from time to time that I might actually take that bet. Probably would, because a 90% chance of winning is much better than a 50% chance of winning. Not as great as 95% chance of winning, but it's getting close. So significance is an arbitrary occurrence, and it's not some hard and fast physical property. It's just a value that we have determined that we're going to look at 5%. Oh, you know what I didn't do? Why didn't somebody yell at me? I didn't share the screen. That was particularly stupid on my part, and I apologize, but let's go back and kind of reconstitute that just a little bit. And so here is what I was talking about, this distribution. And the mean value is in the middle. Standard deviations +1, +2, -1, -2. Within that range lies 95% of the cases. And so that's a mean ±2 standard deviations. Now, minimum and maximum just means the lowest value and the highest value. And in and of itself, that may not mean anything at all. Just like the mode may not mean anything at all. The mean is useful. The median is somewhat useful, because it allows you to know the point at which half the cases are above and half are below. But the most meaningful things you can get out of descriptive statistics with a little simple math is this notion of what's outside of this middle 95%, and what's outside out here are the really significant things to look at. Anything that's in the middle here really doesn't matter. I mean, those are considered to be all within the range of random error, possible error, random error. Another way to think about it, in this middle 95%, we consider that to be in the range of random error. If it's outside of that, in these outside tails, then we consider that to be more likely systematic error. It helps when I have the visual up, doesn't it?
Yes, it does.
Sorry about that. I'm a little, maybe still just a touch off from the day, but probably not. I'll be fine. Other questions, please?
I have a question that may just be semantics, but I wanted to make sure I was saying it correctly. When we talk about significance and the p-value, if you're talking about it being greater or less than, is it correct to say something is significantly greater than the other thing?
Sure.
Or, okay, I just want to make sure I was using that
Well, let me get
correctly.
to that. Unfortunately, this graphic is getting too messy here. I'll have to draw another one, but I think I can manage that. Hold on just a second. And this time I'll even share the screen.
And the reason I ask is because I hear people say the word significant a lot, like this is a significant difference, but I wonder if it always means the way we're using it as in a statistical sense.
In a technical sense, yeah, it always means the same thing, but it's just a matter of the statement, how the statement is made, and what the question is. In stats, there are what are known as two-tailed. Let's get this thing to focus up. There are what are called as two-tailed questions and answers. And there are what are called one-tailed questions and answers. Now, if you think about the descriptive name of one-tailed and two-tailed, if you are looking at a two-tailed notion, I'm about to blow this all to pieces here. If you're looking at a two-tailed notion, you really are interested in both ends of the distribution. And the question for a two-tailed question would be something like, are these two things different from each other? Are the scores by one group different from the scores by another group? Now notice it just talks about difference. And in that case, when we say there's a significant difference between these two groups, we mean that there's a less than a 5% chance that we would be wrong if we said those two groups are significantly different from each other. Now, if you're talking about a one-tailed statement, we could be interested in 90, 10, or excuse me, 95 and 5 in just one direction, the high direction. Or we could be interested in $95 and 5 the other direction. So when you're doing two-tailed test, you have about 2.5% of the volume of the area at each end of the tail that you're interested in. And that's that 2 standard deviation unit notion. But when you're talking about a one-tailed test, you're only interested in one particular end of the distribution. And let's say we were talking about difference. And we had, say group A, group B. So we had group A and group B. If we want to know, is group A greater than group B, that's a one-tailed test. And we'll look for the answer somewhere out, does that value lie out here someplace? That would be, is group A greater than B? If we were asking, is group A less than B? Then we would be looking for significance or a value that's somewhere out here at the bottom end of the distribution. And so those are called one-tailed tests because we're only interested. So if somebody says the statement, this is significantly greater than that, or this is significantly higher than that, that makes it a one-tailed test. Now, one-tailed tests are more sensitive than two-tailed tests because you have 5% of the area all at one end of the distribution, as opposed to just 2.5 on each end. And so it's often that you'll find a significance that's a one-tailed significance when you might not find it for a two-tailed question. And so the two-tailed question, are these two groups different from each other? The one-tailed question, is one group greater than the other or less than the other? And so when people are talking about significance, you need to pay attention to what they're actually saying, and then take a look to see if they actually did that. Did they actually look at a one-tailed or a two-tailed or whatever? And the JAS program, all stats programs allow you to determine what sort of hypothesis you're looking at. Are you looking at a hypothesis that's related just to difference, or are you looking at a hypothesis that's related to difference and direction?
Okay,
Does
thank
that
you.
help?
Yeah, that was helpful. I mean, I had the question. I wasn't even exactly sure what I was asking. I mean, so that was really helpful to put it in that context. Thank you.
Yeah. Once again, it's just a matter of the logic of the thing. What is
Yeah.
the logic of the question? Yeah.
Are these tailed tests also called t-tests?
Oh, yeah. Yeah. In
Okay.
fact, well, not all statistical tests have a directional component to them. For example, analysis of variance is very often not a procedure that we really talk about one-tailed or two-tailed. But t-tests can all be either one-tailed or two-tailed. And when you're looking at z-scores and is somebody significantly higher than the rest of the group or significantly lower than the group, once again, then you get into looking at just one end of the distribution. And so that becomes a more sensitive test to answer that particular question. But if you're talking about difference, they're all, two-tailed. And analysis of variance, the reason it's not typically treated as a one-tailed or a two-tailed test is because you're looking at lots of different group comparisons and interactions between group comparisons. And so it would just be kind of foolish to think of that in terms of, directional in nature. And when I do the big description of analysis of variance, on the video this coming week, I'll kind of play with that notion a little bit too. But it's not some things are just not one-tailed and two-tailed, but t-tests certainly are. T-tests are one-tailed and two-tailed, depending upon the question you're trying to answer. What's the hypothesis that you're testing?
When we upload this midterm, are you wanting our JASP file included with it or
Just
just
tables,
the
Just a
snippets out
table.
of it?
Yeah, just the snippets out of it, just tables.
Okay.
And that's one thing about JASP, it's really simple. I mean, you just, click on a table, highlight it, copy it, and paste it right in. Other programs, SPSS, for example, and SAS to a certain extent, you have to play around with the edit just a little bit to make sure you get the table, looking like what you actually saw. But with JASP, it's very straightforward. You just copy the table and paste it right in. Now, it's due Friday night. Saturday morning, I'll put up a answer file and also a video in which I'll kind of walk through the whole thing. And by then I will have taken a look at yours probably and have tried to figure out, exactly what you did or what you didn't do or what was right or what was wrong. But it's also, available for you to self-check that with the answer file. And so these things are primarily formative in nature. So it's not really we have to look at it like it's a graded thing, but these are not graded in my mind in any way. These are a formative process to help the learning curve.
And I believe you said in a previous Zoom that we could fix ours and turn it back in.
Yeah, you can. That really doesn't make much sense though if we're treating it like a formative thing. But yeah, and I always put up a kind of a parallel set of questions with the answer sheet. I said, okay, look at it this way. Look at this and see if this get the answer to this one, which is essentially the same procedure, but just using slightly different data.
Okay.
Now, will you see a grade pop up on the grade sheet for as you learn? No. You'll get the feedback. You'll get the answer sheet. You'll get the video. You'll get all of that, but it's not really done for a grade because it's a formative exercise. Other questions? This is way too easy. You need to. I'm kidding. I'm kidding around. Keep it light. Don't get all worried about this stuff. This is a skill that you need. This is a piece of the puzzle to be the professional that you want to be. And it's not something that you struggle with worrying about a grade or anything like that. You're accessing or beginning to access a skill that you need to, become the professional that you want to be. And, this is just an entree. This is opening the door sort of thing. And then once you get in there, you kind of grow from that and you begin to learn things that you need to know when you need to know them. And, that's always the mark of whether you've learned something or not, is can you use it when you need to use it? And so you'll be confronted with lots and lots and lots of data I mean, it's the only thing that's consistent across, all the different fields that we deal with is the data that you will be confronted with. And so it's just a matter of making some sense out of the data, trying to talk through it. And when I do the video, for this assessment, you'll find that I'll also talk a bit about, what does this mean? What can we say based on this? And you'll find that not only, as a mentor of mine once said, the data tells its own story. You don't get to tell the story. The data tells the story. Now, what you make out of it, you do get to do that. And so you can ignore the data at your own risk, or you can, misinterpret the data or conflate the data a little bit at your own risk. But the data tells its own story. I mean, the data says what the data says. And if it's good data, the story will be a true story. If it's bad data, who knows? And so it's kind of garbage in, garbage out sort of thing. So you're always worried about, is this good data? Is this data that has reliability and validity behind it and all that? And if not, then you might as well, not even fool with it. But if it is, then yeah, it's good data. When I first got to Harrisonburg years ago, it's a fairly small little city. I mean, it's now it's up around 50,000, but back then it was maybe 30,000 or 25,000 or so. And they had the one horse TV station, and that the people that worked at that TV station were either brand new out of college, out of a journalism program, or on their way down from an unstellar career someplace. And so they didn't have the greatest of folks to work with. And one of the first stories I remember had to do with the space shuttle and getting ready to get the space shuttle off the ground. And they did a story in which they said the citizens in Harrisonburg, 50% of the citizens in Harrisonburg believe that the money spent on the space shuttle could be better used for other purposes. That's just a waste of money and something that we don't need to do. And the very next line they say, of the 4 people we talked to on Court Square, 2 said. Now, had they not done that and realized how stupid it was, what they said to begin with, you could have gone with the line that 50% of the people in Harrisonburg didn't believe that we should be spending money on the space shuttle, when in fact, instead of 12,000 people, they were talking about 2 guys that were hanging out on Court Square in the middle of the day, which means they didn't have a job anyhow, or they were, bums anyhow. So what was the point of the story? Well, there was no point, because the data was crap. It wasn't valid. It wasn't reliable. It was just lousy reporting on bad data. And so you have to also know the context of the data. In the field that you're working in, you need to know the context of the data to know whether it's good data or not. And so you need to know who collected it and how it was collected, and all those sorts of things. And so it is the whether something's significant or not, whether it's a one-tailed or two-tailed, all those things are meaningful, but they only mean as much as the quality of the data. And so you always have to ask, with a little bit of a critical eye, you always have to ask that question, how was the data collected? What did it look like? And things like that. But this is a stats class. We're not, we're not getting into that realm, quite as much as sometimes you'd like to, but we will approach that from time to time over the next 3 or 4 weeks, as to how good a quality is the data, because where does it come from? Questions? Other questions, other thoughts? Well, I'll not bore you with it. You know, and so, you know, if you, something pops up between now and tomorrow, you know, shoot me an email and I'll cover it tomorrow night and record it if you can't, you know, make tomorrow night. And you'll get your answer then.
That sounds good. Thank you very much.
Okay? Everybody okay? Ryan, you good? Okay.
All right.
All right, folks, I'm gonna go catch a little rest. I'm a little tired. And of course, I may have a glass of wine before that, but you know, you have to, it takes a little bit of, you know, consideration before you can actually get rested up. So anyhow, I will, if you have questions or just want to see if other people have questions, I'll be at this same place, 7 o'clock tomorrow night.
All right. All right. Take care.
All right, folks,
Bye.
have a good evening.
Thank you.
Bye.